Germany has taken a decisive step in modernizing its air defense capabilities by selecting Munich-based Tytan Technologies to supply interceptor drones for the Bundeswehr. The program, valued at several hundred million euros, is designed to strengthen protection against the growing threat of medium-range unmanned aerial systems. Recent conflicts have shown that traditional jammers and short-range guns are increasingly ineffective against this new class of drones, creating an urgent need for a more adaptable and cost-effective solution. By investing in a domestic provider, Germany not only enhances its operational readiness but also reinforces national industrial capabilities and software sovereignty, ensuring that key technologies remain under domestic control. Titan's interceptor drones represent a significant shift in approach, combining speed, agility, and autonomy with precision targeting to neutralize hostile aerial threats. Each interceptor is capable of high-speed pursuit, with sprint speeds exceeding 250 km per hour, and is designed to engage targets at ranges between 15 and 25 km depending on the variant. The drones can carry either a unitary kinetic payload or a fragmentation charge equipped with a proximity fuse, providing flexibility for a variety of engagement scenarios. Visual tracking, fused electro-optical sensors, and computer vision allow these interceptors to maintain a hard lock on targets even in cluttered environments or under electronic attack, while a data link allows human operators to intervene during launch or terminal phases if necessary. This combination of autonomy and human oversight ensures rapid reaction times and highly reliable target engagement. The launch architecture is modular, enabling deployment in multiple configurations. Interceptor rails can be mounted on light vehicles for mobile defense or packaged in ISO containerized units for semi-fixed protection of critical infrastructure such as air bases, depots, and energy nodes. Each module can house multiple ready-to-fire rounds with automated battery conditioning and health monitoring, allowing a small crew to sustain high operational tempos. The system's software center command station integrates radar, AO/IR, and acoustic sensor data, while also ingesting third-party tracks to create a comprehensive engagement picture. This fusion capability allows operators to respond quickly to evolving threats, while the emphasis on software sovereignty ensures Germany can update tracking algorithms independently as adversary drones become more sophisticated. The Titan system fills a critical capability gap between low-cost RF jammers and high-end surface-to-air missile systems. It is designed to counter Class II reconnaissance drones and one-way attack systems, including models similar to Shahid drones, which combine modest speed with long endurance. By providing a rapid, attritable response to these threats, the Bundeswehr can conserve its more expensive missile systems, such as Patriot and Iris-T, for higher-end engagements. The autonomous chase profile of the interceptors reduces operator workload during mass drone attacks, allowing multiple drones to be engaged simultaneously with minimal human intervention. Early operational data from Ukrainian forces has demonstrated the resilience of Titan's flight control systems under electronic interference, offering valuable insights for Germany as it develops tactics for future deployment. The broader context for Germany's investment in Titan interceptors is a European shift toward layered air defense architectures capable of absorbing persistent low-cost aerial threats. The conflict in Ukraine has normalized the use of inexpensive, small-scale drones for reconnaissance and attack purposes, highlighting the limitations of legacy point defense systems. Countries across Europe are recognizing that defending critical infrastructure and military installations requires a combination of low-cost, high-volume systems and traditional high-end missile solutions. By selecting a domestic startup, Germany ensures that core development and integration work remains under national control, supporting both operational and industrial objectives while contributing a NATO-relevant capability. The Titan program also reflects a pragmatic approach to modern warfare, where attritable threats demand attritable solutions. The containerized interceptor modules allow for overlapping sectors of coverage, enabling rapid deployment around bases, energy facilities, and key transport hubs. Mobile sensors can be paired with the system to provide real-time tracking and engagement, offering flexible defense options without exhausting strategic missile inventories. If the demonstrator system performs as expected in 2026, it could become a cornerstone of Germany's layered air defense strategy, providing a scalable, cost-effective means to address the persistent challenge posed by medium-range drones. From a strategic perspective, Germany's adoption of Titan interceptors signals an understanding that future conflicts will increasingly feature swarms of small, inexpensive drones capable of saturating traditional defenses. The ability to respond quickly and repeatedly without significant resource expenditure is essential to maintaining operational effectiveness. Moreover, the domestic nature of the program supports industrial autonomy, ensuring that Germany can adapt and upgrade the system as threats evolve without dependency on foreign suppliers. This alignment of tactical necessity and industrial policy underscores the multidimensional benefits of the Titan selection. In operational terms, the system enhances the Bundeswehr's ability to defend critical military installations, energy infrastructure, and transport nodes from persistent aerial harassment. Each module can sustain rapid firing cycles, while the autonomous pursuit capabilities reduce the need for constant human oversight. This allows defensive units to manage multiple simultaneous threats and maintain a high operational tempo even during complex scenarios. The integration of multiple sensor types into a single command and control framework ensures that operators can respond with speed and precision, creating a layered and resilient defensive posture that is both cost-effective and operationally robust. Germany's decision also carries broader implications for European defense planning. By investing in a low-cost, highly agile counter-UAS system, Berlin signals to both allies and adversaries that Europe is committed to developing scalable solutions capable of countering attritable aerial threats. This approach complements high-end missile systems and provides NATO with an additional tool for defending critical assets against modern aerial challenges. The combination of domestic industrial support, rapid response capability, and autonomous operational efficiency positions Titan interceptors as a model for the next generation of layered air defense systems. Ultimately, the Bundeswehr's adoption of Titan Technologies interceptor drones reflects a forward-looking strategy that balances cost, capability, and flexibility. By integrating high-speed, autonomous interceptors with modular launch systems and advanced command software, Germany is creating a layered defense capable of countering the medium-range drone threat that has emerged in recent conflicts. This initiative strengthens both national security and industrial sovereignty, while providing NATO-relevant solutions for a new era of aerial warfare. With the Titan program, Germany is embracing a modern approach to air defense, one that combines attritable solutions with strategic foresight to ensure readiness in an increasingly contested airspace.